Under the forest re-echoed the sound of the song that they sang as they met. Is in Namorata had just
no, apparently the camera's got sound on it.
And lifted her voice in duet, falsetto. My glorious love, nothing quite like it for cooling the blood. So hold it alone, don't hold her alone, and there let us walk in glorious love.
Welcome back to the second half of our 2018 Lectures for Children at UEA. Now we're going to meet Brian Reed. Brian Reed works in the School of Environmental Sciences here at UEA, and he studies soil sciences and loves getting his hands dirty. And we hope that some of you might join him on stage today to find out about the incredible things that soil does for us. Thank you.
Thank you very much. Excellent. Well, good morning, everybody. Thank you for coming along. Thank you for the introduction and the great opportunity to be here this morning and tell you all about the wonderful things that soil does for us. So hopefully I can tell you some new things and give you a little bit more of an insight into why we really need soil on the planet for people and so we can survive and continue to survive on the planet. So I'm going to start with a question. Who likes mud? Yeah, we're doing okay. I think there's not so many mums and dads with their hands up. Good. Okay, I reckon that's about half of you. So my job today is to try and improve on about half of you between now and the end of the Christmas lecture. Okay, so let me just tell you a few things, and these would probably be quite obvious as to why we need soil. And the first reason is that we really rely on soil for most of our food, our timber, and our fabrics. So if we want things to eat, we need our soils to be healthy and in a good condition so they can continue to provide that food for us. The other really important thing that soil does, and we'll explore this with some demos in a minute, is that soil acts as a sponge. Okay, so it soaks up water. And that's really important that soil does that effectively for a couple of reasons. One of those is so that the soils can store water, and then the plants can get that water and grow all through the year. So I'm sure you all know you have to water your plants. Well, some soils are better at holding and releasing that water than others. Beyond the plants, the other reason why we need our soil, our natural environment, to perform that function for us is to stop floods. So if soils have a very poor ability to absorb the water, rains really hard, all the water runs straight off the field, onto the road, into the rivers, into the ditches, and we see scenes like we have in this photo at the bottom. And that causes a lot of problems, disruption and upset for people, and it costs the insurance industry a vast amount of money as well. So really we have a responsibility to manage our land and look after our soils so the sponge can do its job, and this sort of thing down the bottom, it doesn't happen. The third thing I just want to introduce as an idea, and again we'll have some demos around this in a minute, is soil acts as a filter. So in our fields we maybe use fertilizers and nutrients to help our plants to grow. And one of the really important things that soil does is to filter those chemicals which we're using to try and benefit our food production and stop it leaking out into the wider environment. This is important because it provides protection for our water and it protects the ecology and the life that lives in our water. So what you can see in this picture here is a very green, very algae-filled piece of river. And the problem that's happened here is that nutrients have run from the land and allowed that algae to really bloom and grow to large numbers. Which in itself doesn't look great, but the problem comes when the algae dies and it falls down through the water and it degrades and it soaks up all the oxygen. And all the oxygen in the water, that's what the fish need to live. And so our soils need to filter our land, stop nutrients running into the water so that we can look after the ecology, look after the water resource, and have that as a benefit for our society. And then finally, the third thing I'm going to introduce before we get on to some demos and things is how soil regulates our climate. So there's a really close link, and we'll see this at the end of the lecture, between the land and processes in the land, in the soil, and the composition of gases that are in the atmosphere, which then link to our climate and how warm the climate is or how cool the climate is. So I'm just going to start a little demo down the front here. And what I have, a bit like the picture, is a little soil world. So I've got some soil, some leaves, a bit of compost actually in here. And what I'm going to do is a little bit of chemistry. Let's put some gloves and glasses on. And this bit of chemistry we'll come back to at the end of the lecture. So I want you guys to keep an eye on these flasks for me. And if anything really exciting happens, you let me know, okay? All right, so what's happening here is we're going to put some little pots, little glass pots, which I'll show you in a second. So I've fought my way into these gloves. Okay, so I have these little pots on here. And these contain a reagent that's going to collect carbon dioxide as it comes out of the soil in these flasks. And the way we're going to know that it's come out of the soil is that these are going to change colour. I'm just going to put some special chemicals in. That's one. 3 of these. Two. And the last one. All right, so I'm going to give these a little shake. And as you can see, they've got this dark purpley colour on here. So I'm going to put these inside my jars. And what's hopefully going to happen is the carbon dioxide will come out of the soil. Excuse me a minute, I'm shaking a wee bit here. The excitement of it all. We'll just seal those up. And hopefully, before we finish, all the gas that's come out of the soil will have turned these clear. So you keep an eye on them for me, and we'll see those in about 25 minutes. Okay. Right, so if you've got a bit of paper on your desk, not the flowers, my bits of paper, they're like this, orange and yellow and brown. If you have a piece, what I'd like to do in the interim, just scrunchel those up into a ball for me, and we'll come and collect those in a little while. So just crumple them up, that's good, and we'll be around in a minute or two to sort them out. Okay, right, just hang on to them for now. Right, so I want to introduce you to a couple of people. One of these people you know already is Elizabeth I. The other chap on here, Cornelius Vermuyden, is the chap I really want to introduce you in a minute or two. So their lives, they overlapped. When Queen Elizabeth was about 35, Cornelius was being born into the world, and when Elizabeth died, he was about 8 years old. And he's important for our story, as we'll see in a minute, in so much as he kind of transformed our landscape for us. And the story really begins with maps. So during Elizabeth's reign, there was a lot of desire to know more about our world, our environment, and the land and the assets of the land. And she really pushed forward the need for accurate maps. So I'm going to show you a map in a bit more detail. So this is a map of the area, Norfolk, around Norwich. And my question to the audience is, well, is there anything, features on the map that are obviously missing? I'll come back to you in a second. Keep thinking. Someone else? The what, sorry? Contour lines. Yeah, there's none of those. That's true, but it's pretty flat here, so you got to allow for that. Over here, you got to shout for me. Roads. Yeah, there's not so many roads. That's true. So what I'm really looking for an answer. Let's have you first. Yeah, they might not be on the map because it's quite zoomed out. So something, the Broads, something Norfolk's famous for, the Norfolk Broads, yeah? This map, it's got the main rivers, but the Broads, they're not there. This is really where Vermuyden comes in. So he was a Dutch engineer, as his name might suggest, and he brought methods from Holland, from the Netherlands, across to the UK, and those methods were all about draining the land and allowing the water to be taken away so we could use that land for agriculture and to make some money and to grow some prosperity from it. Did a great job. So later on in his life, he was made a knight, Sir Cornelius Vermuyden, and became a British citizen. And he didn't just transform the area around the east of England, he was also important around the Fens and moving further north through England. So he made a huge difference to our landscape. And his work, as I say, was really about taking marshland and draining that marshland and turning it into land that was productive. So on this picture over here, does anyone know what this is, this structure? A what, sorry? A windmill. So that's a good answer, because it looks like a windmill. But these mills are actually water pumps. So as the sails turn, They don't make corn or grain. They drive a pump that pulls the water out of the ditches into the raised rivers and takes that water away to the sea. And Vermeiden was involved in all of that in order that we could drain the marshlands from being a bog, which is no good, particularly for agriculture, and into something which then fed forward into an industry supporting grazing and sheep, the production of wool, perhaps madder as a dye. And in the last lecture, you would have heard about weaving, Queen Elizabeth's visit, and the fact that, how we use the land links directly into the prosperity and the wealth of Norwich going forward. And it's really the land management which has been at the centre of all of that. So this is the moment we'll all be waiting for. So I'd like 6 volunteers. I've got some helpers, and they're going to come around and have a look for some volunteers. And they're also going to come around in a minute or two and collect up those bits of paper. So if you've got those ready, pass them along as well. Okay, so I think we've got our 6 now. So you can put your hands down, but there's lots more volunteer opportunities. Okay, so as these guys are ready, I'll just tell you what they're going to be doing. So we're going to be working on 2 things. One of them is to do some making with some soil. So we're going to build some figurines. This is a Giacometti sculpture, if you like these. Sainsbury Centre, they have some you can have a look at. So these guys, with the help of the demonstrators, they're going to make some little models out of some soil. And we're going to come and see how they're getting on in a little while. The other guys, the demolition crew in the hard hats and the glasses and the high vis, they're going to do some breaking of soil. And so what I've done here is I've set up different sorts of soils, and we're going to get some evidence from our experiment as to why they're different. So the first thing I'd like to do is for the guys in the hard hats, you want to give them a hand, and they're going to have a look at these soil samples down here, and they're going to do some breaking. Okay, good job. And the other guys at the back here, you're going to do some making, and the demonstrators will give you a hand with that, and I'll come and have a talk to the demolition crew. Okay, guys, so let's have a look at your trays. Do you want to pick these up for us, Carl? So one at a time. Okay, so this tray here, let's have a look at this. Yours, yeah? Was this easy? Pretty easy to smash that soil up? Messy, yeah. So what we have here is a really sandy soil. It doesn't stick together at all well. It's really pretty easy to smash into these little fine particles. Now, how about you? On your soil over here, how did you get on?
Well, a lot of it's felt.
Yeah, but in terms of breaking it, was it easy?
Pretty.
Yeah, pretty. But the difference we have here, just that little way, Carl, is that the sandy soil, it crumbled away into this. But the heavy clay soil, which is what you had, it stays together in these big hard lumps. So kind of what I'm trying to show you here is that different soils have got different properties. Some are strong and some are much more crumbly. Okay? So we'll come back to you guys in a minute. I'm just going to have a look at some slides. You're done though, so thank you very much. Okay, we'll come back to the modelers in a minute. So what we're looking at here is a property of soil, which is really important. It's called the soil's texture. And it basically does what it says on the tin. It's how the soil feels. So the diagram here shows how much sand, or how much clay, or how much silt there is in a soil in different percentages. So if we're over here in this corner, the sand corner, over here, basically all the soil is made up of sand and not very much clay, not very much silt. If we're right in the top, most of the soil is made of clay, and if we're down in this bottom corner, most of the soil is made of silt. So if we have a look at these, I've got some zoomed in photographs. Okay, so sand particles, this is a scanning electron micrograph. Sand particles are huge, they're enormous, 2 millimeters at the biggest. But at this scale, you need to imagine a sand grain. It's as big as the lecture room. Massive, massive particle when we zoom in at this resolution. If we then zoom in, so I've zoomed Just a little black line on the ruler. This is a silt particle, much smaller. So we can have loads of them in the room, way more than one, maybe a few thousand of those silt particles. The little red bit, it shows the biggest size those silt particles will be, just a little black bit on your ruler. And then finally, the clay particles, these are even smaller, so 2 micrometers, so 2/1000ths of a millimeter. It's that little red line on the blurred bit of the ruler, really tiny little particles. And it's the mixture of sand and silt and clay that makes the soil strong or makes the soil more crumbly. So we're just going to have a go with our modelers now and see how they're getting on with their sandy soil and their clay soil. Right, so how are you guys getting on? It's squishy.
Yeah, and it sort of easily breaks.
Yeah, so it's really crumbly and breaky, and your guys need to lie down, don't they?
Get messy hands.
And you get messy hands, yes. Okay, so this is the sandy soil these guys are working with. Hopefully you can see on some of the models. We'll just move this over here. Okay, so there's our sandy man. Okay, so he's coming along, but he's not sticking together great. Good job, though. And that's, well, this little man, he's met with worse ways. But over here, these guys, this is brilliant. So they've got some clay soil over here. And as you can see, it's much more easy to model the clay. So how do you find this? Pretty easy. Yeah, it's good fun, huh? Yeah, so we've got this really sticky clay soil, which is really different to this very sandy, crumbly soil over here. So different sort of materials. So clay, sand. Great. So thank you very much, guys. Yeah, you can wash your hands. Right, so as I get back to the seats, I'll just continue. Okay, so here's another view of soil. Who's this? You going to watch him at Christmas? Yeah, he's going to go on the telly probably, I should think. So Shrek's got a thing to say about onions, hasn't he? So he says this, he says, onions have layers, ogres have layers. You get it? We both have layers. That's how he says it, just like that. And soils, they have layers as well. So these pictures on here, you can see there's different stripy bands in the soil. And I made some models, try and make this a bit clearer for you. I'll just bring them over here. Okay, so what we've got is our 2 models of soils that we have on campus. So this soil over here is really sandy. We've got really sandy topsoil, and then we've got lots of sand underneath that, but it's not black. I'll come back to that later. And then we have some gravel at the bottom. So really well-drained soil, makes up a lot of campus. But the other soil we have looks like this. It's different. Stripes are different. So we've got this much more silty clay soils, lighter, and then we've got this chalk material at the bottom. So this soil doesn't drain nearly as well. We'll come back to that in a minute. And its chemistry is different as well because of the chalk at the bottom as opposed to the flint at the bottom of here. So these soils have developed into very different sorts of soil that do different things. And you also notice they've got some leaves at the top, and I'm going to come back to them in a minute as well. If you just remember, soil's got layers, and it's not just the brown mud that you walk around on. There's all these layers under the ground, and they make soils behave in different sorts of ways. Okay, so we're going to do another demo now. 2 volunteers needed this time. I'm glad you're all keen. It's exciting. Okay, so we got 2 volunteers. That'd be great. So we're collecting up the bits of paper as well. We need all them. I need to pick that up a little bit. So if you've got bits of paper, you want to hand those in. Helper coming around. If you've got paper, anyone? So we've got our volunteers. Just hold up any paper you might have. Okay, bits of paper. You want to try and get those in? Jessica, that'd be great. You got a few more over here. Good. Okay, so we're nearly there with this. So what I want to do with this demo is to look at this idea that soils act as a sponge. And so what we've done is we've crumpled up our bits of paper. So you've had sort of some clay and some silt and some sand. You've crumpled it all up and put it into these bowls that we're collecting. And what I've also prepared over here is another one. Okay, and this one here, all of its paper are flat. Okay, so what we're trying to illustrate here is a soil which has developed quite a strong structure. We'll come back to that with some pictures. And soil over here, which doesn't have such a strong structure. And we're going to do a little experiment to see how well these two different soils can soak up the water. So I'll leave you with the demonstrators. So just pour the water nice and slow and try and catch it all. So not too fast, just pour it slowly. Oops. So we'll just give those a little minute or two to drain. Right, maybe we got another couple of white trays. We got any more trays? Or just a couple of those will do, just to catch the paper and the water. Perfect. Yeah, just pass us one then. Right, so you just want to pop your water on there. Pop yours over here. And if you want to collect those up into the measuring cylinders. Just trying to spill it so we can try and measure how much water has come through. Okay, you want to push them together for me? Okay, so it's a very simple experiment, but it illustrates that we have soils that have got much better structure, all the crumpled up paper, the sand and the silt and the clay all mixed together. We end up with more water being stored in the soil, but where soils have a very poor structure, the water just runs away from them. And you can see in the one on the right-hand side that there's more water's come through that particular demonstration. So hopefully that kind of gives you a picture of how water and soil interacts. Thank you very much again, volunteers. Good. In real life, soil structure looks like this. So you can see in these pictures actual photographs of soil surfaces taken from side on. And we've got this very granular soil over here. You can see it's got little particles all knitted together. But other soils, they look like this. They have big blocks of soil, columns of soil in the subsurface quite often. So it's a prismatic structure or a blocky structure. Or things going flat, like in our demo, very platy sort of structure. So there's a little video now. I'm just going to show you why this really matters for real soils. Okay, so here's two soils. You'll see when it goes back to the beginning that they began looking pretty much the same. So the soil is a big lump of soil, a clod as we call it, and it's sitting in a beaker of water. And you can see this soil on the left, even after 20, 30, 40 seconds, it's still all stuck together. And that's exactly what we want. We want our soils to have really strong structure and to be able to allow water to infiltrate and allow crops and roots to penetrate down through the soil. This soil over here is basically just falling apart. The water's rushed in to the pores within the soil and it's blown it apart. It's got no resistance to that. And these poorly structured soils are everything we don't want. So we need to manage our soils, sometimes with how we use the land, agricultural approaches, and sometimes with adding things into soil to try and help the soil to build a much better, stronger structure so that it provides the services that we need. So it acts as a sponge, so it filters the water, so it mitigates against flooding, so we can grow our crops more successfully. And the structure of the soil is really important towards that. So back to the slides. Okay, so question for you guys. Who's this guy? Oh, Santa Claus is almost right. It's his brother. Okay, let's have you then. Charles Darwin. So he's pretty famous as a scientist. Yeah, we all kind of know about him. Okay, so Charles Darwin, he wrote this really important book over here called The Origin of Species, all about evolution and how we evolved over millions of years. But he also wrote another book his other book, we wrote several, but this other book that he wrote is called Vegetable Mold and the Action of Worms. And when he was alive, this was the big seller. This was his hit. This is the one that put him on the stage as a scientist. The Origin of Species, that's made him famous now, but back in the day, it was this observations about soil, soil development, and earthworms that really put him on the stage. And he basically noticed that soil and worms together are much better structured. So this big clod of soil over here, as you can see on here, hopefully, okay, you can see the soil's all sticking together. It's got a fabulous structure. Loads of earthworms in this soil, lots of organic material in this soil. We're going to talk about that next. And because of that, the soil's really well structured, lots of pores, exactly the sort of thing that we need. And Darwin was really interested in how worms achieved this in the soil, but he also noticed, like a bit like magic, that if we have a soil with these leaves on the surface, of course they disappear. They're not there next summer. They fall off the trees in the autumn, and they degrade. So they turn from being like this, leaves, into lovely organic matter-rich compost or humus, soil humus material. Okay, and this is really important for the soil and how it behaves. So just soil on its own, sort of mineral with a little bit of this mixed in. That's kind of what soil is. But we need the leaves to turn into this and be mixed up with this to give us a really healthy soil that we can grow things in. And it was Darwin really that made some of these really key observations. So what I set up a few weeks ago was this wormery. Just want to go back a little. Okay, so these wormeries, they started off with nice bands of soil. And I've given them basically almost 2 months now. And you can see that after a few weeks more, and now, if you just want to go to the film feed, our worms have taken all the leaves, because there was lots of leaves in here to begin with. They've broken them down, they've mixed them into the soil, and they've mixed up all these soil layers. So we really need, within our soils, to keep the soil animals happy, because the soil animals, they provide the structure, and they allow the soil to have its function and deliver the services that we need. So the worms are hugely important towards those ends. If you fancy it, you can buy these little wormeries. I'm not on commission, but it's a good fun thing to do. You can see how the worms mix the soil. We've got some worms here. Look at these guys. It's a bit disgusting. Okay, so we've got some worms here. Look at all them. Yeah. So what we can do with the wormery is we can put these worms in here, and after a few weeks, they'll have mixed all this soil up. Give them a few leaves as well. There we go. Okay, that's just what they like. And we need those worms to like doing that because that makes our soil really healthy. Okay, so that's kind of a fun thing to do. The other thing that lives in the soil, which is really important, are microorganisms. These are tiny little things, even smaller than the clay particles. Okay, so this is zoomed in on a microscopy using a microscope, so you can actually see the single cells. But here's a little fact, fascinating fact. If you take a teaspoon of soil, that little teaspoon of soil, if you were to count all the microbes that live in that teaspoon of soil, there'd be more of them than there are people on the planet at the moment. Okay, there's easily several billion cells in that little teaspoon of soil. And these microbes are really important, and one of the key things they do is to help the worms to turn this stuff, the leaves, into compost like this and allow it to fertilize the soil and make it healthy. So this takes me on to compost, and that's exactly what compost does. So who's got a compost heap? Yeah, I see quite a few. So you take your vegetable waste, and you've realized no point in sending it to the landfill. We can take it, put it in a compost heap. We can have some worms and our microbes, and they'll break it down into this lovely compost over here, and we can add that to our garden to make it much more healthy. Okay, so it provides nutrients for the soil, and it helps the soil to structure. So one more demonstration about soil and water, and I'm going to need 3 volunteers for this one. Our demonstrators will come round and pick some people out. Had a panic there. Okay, we've got 3, so that's fine. Right, so in our next little experiment, Thank you, volunteers coming down. Okay, so what we're going to do this next experiment is we're going to have a look at some mixtures. Okay, so we're going to mix soil and compost together. That's going to go in the first one. So if you want to get on with that, it's great. Second one, 2 bags of soil. They're going to go into this pot. And the last one, 2 bags of compost. So we just give them a chance to get their stuff in. Give him a hand, Kyle. Help him out there a bit. Hold things. Well done. You did pretty well there, everybody. It's all going well, sorting itself out. Okay, so just to remind you, compost only, soil and compost. And now we're ready. Our volunteers are just going to help and put some water in. So they've all got a flask of water, all the same amount of water. Whoa, 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 whoa. It's all right, you got most of it. I'm glad you had a funnel there. Okay, so you're going to put the lids on and give these a little sugar around for a minute. Good, right, that'll do. Okay, so if you want to take the lids off and just, with the help of your demonstrators, we're going to pour the water back out the pots into the flasks. Probably do it without a funnel, I think. I would just do it without a funnel. Just slowly, you don't want big lumps of stuff falling out. Okay, so this is our compost only at the moment. You can see that's not very good in terms of the water coming out, but that's exactly what we want. We want the water to be absorbed in the compost, to store the water, give it to the plants. If we have a look at the soil now, well, we've got quite a lot of mud coming out there as well, but hopefully you can see that the difference between compost and soil is huge. It's enormous. And if we mix the two together, our soil and compost, we end up somewhere in the middle. Okay, so this is exactly why you make the effort, to collect up your vegetable peelings, to make your compost, and add it into the soil. Because it's you doing your little bit to make the soil healthy, to give the soil the food that it needs for the microbes and the worms, and for the soil to absorb the water in a way that will stop those floods from happening. So there's loads and loads and loads of attention being given to increasing our soil carbon stocks with compost, manures, sewage sludge, all sorts of things, but they help to make the structure strong and healthy like this. So thank you very much, volunteers. Right, these might be a little longer. Just give me a second. Right, so these got a little bit more pink. I'll come back to them in a minute or two. So the last thing I want to talk about this morning is about soils and climate. So we set up these little experiments at the start. They're starting to change colour. I'll give them another 5 minutes and see if they change a little bit more. So our final thing now for demonstrators, if you want to get yourself sorted, I need 10 volunteers. 10! Okay, so you 10, if you want to just come down here to the front, that'd be great. We're going to bring you some balloons in a minute. 6. So I've got 10 down here, 10 people. Demonstrators, I've got 10. Nine, maybe. Can hear the little rumblings. Oh, he's not got 10. Right, so you guys, you're all going to get a set of balloons to hold on to. So demonstrators will help you out with those. All right, once you've got your balloons, I want you to go and bumble around. Just meander about the front here for me. So demonstrators, you can maybe help with that, the ushering. That's good. That's exactly what I need. Keep going all the way, spread out along here. So you guys with the balloons, just wander around the front here. Okay, so a bit wandering about. Just keep milling around. Okay, that's good. That's it. Just keep mixing about. Right, so our volunteers, these are carbon dioxide molecules. Keep bumbling about. Okay, so up in the atmosphere, we have a really important gas called carbon dioxide. There's not a huge amount of it, but it's really important because it regulates the warmth of the planet. It has this greenhouse effect you might have heard about. So it's got a carbon, on here. It's got a carbon atom in the middle, 2 oxygens, carbon dioxide. And it comes out of chimneys or cars when we burn fossil fuels. And we're really concerned about carbon dioxide levels increasing because it makes the planet warmer. And this climate change gives us extreme weather and droughts and problems. So these are molecules, they're all milling around. And now we're going to explain how trees and plants and soils are important in regulating the exchange of gas from the atmosphere into plants and into soils. Okay, so this is what I'm calling the circle of life. Okay, so what I want you guys to do, this is our atmospheric carbon dioxide, and the tree's growing, and you guys are all going to grow into a tree. So we need to get all together, maybe lock arms, hold on to your balloons. So we're capturing carbon dioxide out of the atmosphere. Get yourselves all together. Demonstrators, can you help? Get yourselves all together, all locked up together. That's good. Okay, so on my diagram, what we're seeing here is up here. So we've got atmospheric carbon dioxide in the atmosphere, and the trees, they collect it. All the leaves, the carbon in the leaves, came out of the sky. So trees are really important for moving climate warming, carbon dioxide from the atmosphere into the trees and growing maybe fruit and veg for us, or a tree or a plant or a bush. But when those leaves fall off and reach the soil, over here like this, they start to break down and decompose, and they turn into compost like this. And so 2 things happen. So if you all just want to let go of your balloons now. Okay, so what we're seeing, oh dear. Right, they'll be up there for a while. Okay, so 2 things happened here that are important. So the first thing that happened, come a slide. The first thing that happened is that some of our plant, carbon, got incorporated into the soil. So on the ground. Okay, so that's really important. We moved carbon dioxide from the atmosphere into the ground to feed the microbes, to feed the worms, to get much better soil structure. And some of it went back up into the atmosphere, these balloons up on the top of the lecture theatre. Okay, and this circle of life is what we need to happen. We need trees to collect carbon, to feed the soil, for the carbon to be released into a circle. It's just this circle of life idea from the Lion King, which hopefully you'll remember. The problem we have on the planet is that we're making carbon dioxide other ways. We're burning fossil fuels, driving cars, things like that. And so the amount of carbon dioxide is going up and up and up and up, and it's not, the trees can't put it down fast enough. Okay, but hopefully that was helpful. Some carbon gets stored, some of it gets put back in the sky. Thank you very much. Okay, so we've learned a lot about soil, what it is, its properties, how it behaves, how water behaves with it, some of the biology that goes on within soil, And I've tried to get across this idea that soil needs to be healthy. We need it to provide functions and services for us. Of course, we don't always get it right. Okay, so I'm going to show you some slides, a little bit of video of how really poor soil management, us, people on the planet, behaving in a way which is bad and damaging to the soil, causes problems. So if we go back, not quite 100 years ago, but to the United States in the 1930s, there was a thing called the Great Depression. Everyone's sad, okay? And they were sad because there was a drought and because the harvest failed. Year on year on year, the harvest failed. And what you can see in this picture here are great big dust storms which blew around the landscape. Soils are dry, no organic carbon, no strong soil structure. Land basically being damaged by really poor practice, agricultural practice. And that made the system unable to cope with the drought. And people went hungry, people were poor, and it was our fault. Our fault for not looking after the land properly. There's another picture here. So you can see cars and carts, bicycles, and they're buried in soil. They've not sunk into the soil. The soil's picked up into the sky, big dust storms, and been deposited on the landscape. 6 years of drought, because of the poor land management, ends up looking like this. And so some of you guys will have, others will at some point perhaps, read a book by John Steinbeck called The Grapes of Wrath. It's all about the Great Depression and the fact that really poor land management resulted in the problems that went on for almost half a decade. A little picture here. This is a dust storm taken from space. Enormous, enormous dust storms. I was going to play a video, but I'm going to move on for it. Lots of videos of dust storms online you can have a look at. Okay, so to conclude, kind of my take-home messages for you guys is we really need healthy soil. You've seen lots of reasons why that's the case. Behind all of that is food security. That if we want to have enough food for the people on the planet, we need to have soils which are healthy and able to provide that for us. So currently we have about 7 billion people on the planet. We're expecting to have another 2 billion people by the middle of this century. And those people will need food to eat, and we need to be able to grow that food. And if we don't look after our soils, then we won't be in a position to be able to do that. So as well as saying Merry Christmas, and I hope you enjoyed the lecture, what I really want to say is we need to look after our soils. If we look after our soils, they'll look after us, and we all have a responsibility for that. So hopefully you can go out and be ambassadors, and I hope you enjoyed the Christmas lecture.
So just some final thank yous for me. Thank you all very, very much for coming. Thank you for all the volunteers that helped so well this morning. And don't forget that feedback card. That email should be with you probably when you get home. So send us out what you thought, and we'll see you here next year. Thank you very much. Goodbye.
Who likes mud? Good. Thank you.